Hello everyone, myself Krishna Reddy. I did my masters from JNTU Hyderabad. I did my Ph.D. from IIT Kharagpur. Today I will be discussing about the numerical problems that were given in TSPSC AEE examination that was happened yesterday, that means that is on 22nd January 2023. So moving on, to begin with, we will be discussing about the numerical problems have given from transportation engineering subject. In total, we have got 16 questions out of 150 questions in technical paper from transportation engineering subject. The very first question is also from the transportation engineering subject. So therefore, we will be focusing on the transportation engineering numerical problems. We will try to discuss, we will try to understand the numerical, we will try to understand the concepts of transportation engineering which are related to the questions asked by TSPSC AEE examination. So to begin with, question number 1, the question is, which of the following statements cannot be used to describe free flow speed of a traffic stream? The moment we see the questions about the traffic stream, we have to understand that the question is somewhere related to a linear relationship called flow speed density, where Q is the flow, U is the speed, K is the density. So this is the linear relationship for a given traffic stream. The question indicates that which of the following statements cannot be used to describe free flow speed condition. This free flow speed can only occur when the flow is maximum. So therefore, this linear equation changes something like this: Q max is equal to UF divided by 2 into KJ by 2. మరి ఈ రిలేషన్ ఎలా వచ్చింది? How this relation has come? This relationship has come from the fundamentals of the traffic engineering, the basic definitions of traffic engineering of the speed. Say if we consider the speed on y axis, density on x axis. Density, if we look at that, density indicates the number of vehicles present in a given section. That means vehicles per kilometer. A speed is kilometers per hour. That means distance per time, and here is number of vehicles per kilometer, number of vehicles present in a kilometer. And if we look at the relationship between these two, when the speed is so high, that means free flow speed, this can only happen in the midnight. So that means a free flow speed that can be written as UF. UF indicates free flow speed. And density, the extremum of the density could be the jam density, that means the traffic jam, KJ. So that is where the relationship has been written. So here, if we look at the relationship, when the speed is free, that means free flow speed, right? So that can happen only in the mid time. That means during that time there is no vehicle present in the particular given section. So therefore, when the speed is so high, density is 0, KJ is 0. And now if the density is so high, that means the extremum traffic jam condition, so in such a case there will not be any speed of the vehicles, there will not be any movement of the vehicle. So therefore, when the jam density is larger or when the jam density is higher, the speed is 0. When the speed is high, the density is low. So therefore, there is a linear relationship between these two. How? Let us try to understand. If the speed is getting reduced, when the speed is going to reduce, the speed is going to reduce when the number of vehicles present in a section is increasing and increasing and increasing. Further, if it goes beyond certain point, that point is a KJ. So beyond that, the speed of the vehicle is going to be nullified. It is almost negligible. negligible. So therefore here UF is the first option is UF is the speed when flow is negligible, when flow is negligible. See here, which of the following statements cannot be used to describe the free flow condition? UF is the speed when flow is negligible. Flow cannot be negligible anytime. See here, the relationship between these two is, although it is linear, both are inversely proportional to each other. So therefore, when we try to explain about this free flow speeds, flow cannot be negligible. And if we look at, for instance, if we look at the option number 2, UF is the speed at which the flow is maximum and density is optimum. Of course, this can be used. UF can be something like when the flow is number of vehicles passing the section is the flow, and density is number of vehicles present in a section. So that can be optimum. This is possible. And UF is affected by geometry of the road. Yes, if the width of the road is so high, the vehicles can freely float on the section. And UF is the speed when the density is negligible. See here, when the density is UF is the free flow speed when the density is negligible in the sense when density is 0. When the density is 0, then only UF is possible, UF speed is possible. So here the following statements which cannot be used is flow is negligible. That means if U is 0, Q is going to be 0. If Q is negligible, that means it is 0, then U is not at all possible. So therefore, this option is the correct option. Moving on to the next question. The maximum number of vehicles observed in any 5-minute period during the peak hour is 150. So therefore, here the 5-minute peak hour traffic is given as 150 vehicles, and the total traffic of the peak hour is 1200 vehicles, that means capital V. Usually the moment we see such kind of questions, we should get an idea about the peak hour factor that is there in the traffic engineering, PHF. That means that can be defined as it is the ratio of the total traffic divided by the 15-minute traffic intervals, 15-minute interval traffics. So here usually we study this formula when we discuss about the synopsis of this traffic engineering subject. But trickily, this question has been modified, rather giving the 15-minute period, here he has given 5-minute period. So here the 5 minutes can be in a given hour, there can be 12 such 5-minute periods, So therefore this PHF can be written as capital V is the total traffic observed in the peak hour, and then such 12 5-minute traffic levels. So this can be modified as something like this. And here if we consider only 15-minute time intervals, then in a given hour there can be only 4 15-minute time intervals. So in this case we have 12 5-minute traffic intervals. So therefore here it can be calculated something like this: 1200 divided by 12 into what is the V5? V5 is 150. So if we do this, we get option 0.67. Moving on. The next question is, it is also related to traffic engineering, and it is also related to the traffic stream fundamentals. On a section of a highway, the speed density relationship is linear and is given by V is equal to 100 minus 5 by 6K, where V is in kmph, K is the density is in vehicles per kilometer. The capacity of this section of the highway would be, so what he is asking is, he is asking us to calculate the capacity. What is mean by capacity? Capacity is nothing but the maximum flow, Q max. So here, since we have seen the fundamentals of the traffic engineering, the basic relationship between flow, speed, density earlier for the first question, where the Q max is equal to UF, that means free flow speed, divided by 2 into Kj by 2. Sir, how we got this equation? Again, memorizing the relationship between the speed, density, and then the relationship between speed and then flow, and if we consider the again relationship between flow and density. So let us try to transform one onto the other. Earlier we have seen that the speed density relationship is linear. So when the speed is so high, density is going to be 0. When the density is so high, the speed is going to be 0. So where density high condition is nothing but traffic jam situation. When the density is 0 means that may be during the mid time. During that time only most of the racers will come onto the roadways and they will move at the higher speeds, right. So again transforming this onto the next relationship between speed and flow is, when the free flow speed is 0, that means speed can be 0 when the traffic jam condition occurs, that means vehicles passing through a section is 0. So therefore it is 0, flow is also 0. When the speed is so high, that means free flow, during that time also flow can be 0, that means during the midnight time. So during the midnight time ideally. So if the speed is increasing, flow, the number of vehicles passing through the section is also going to be increases, and that can also happen to some extent. And beyond the maximum capacity of a given section, the speed is going to be increased, but with reference to the flow is going to be decreased. The flow is decreasing means it is getting late night. So therefore at midnight or maybe 12 o'clock or 1 o'clock or 2 o'clock or 3 o'clock, the speed is going to be maximum and operating speed is going to be maximum, but there are no vehicles. So this is another kind of parabola. And come back to the other relationship between flow and density is, if the density is 0, that means maybe during midnight time, and flow is also 0 because the number of vehicles passing through a section is also 0. If the density is increasing, that means there are number of vehicles that are present in the road section. So therefore if the number of vehicles present in that section is some x, so therefore the flow can also happen. It is so happens that when the flow reaches to the maximum point, beyond that means it reaches to the maximum capacity. Beyond that, it may not be able to serve in an effective manner. So therefore what happens, slowly density increases, but the number of vehicles passing through that section is going to be 0. So the flow is 0 at two instances, when no vehicle is present in the section and when most of the vehicles are present in that section. So that can only happen whether the density is 0 or otherwise jam density. So from this relationship we can link this question. Now the question is the capacity is a maximum flow. So the capacity of this section of the highway would be, so there is an option A. There is an option A called free flow speed is 100 kmph and jam density is 120 kmph. So therefore let us try to calculate Q max for the option A. So from the option A, it can be calculated as something like this, 100 by 2 and then 120 by 2, right, 100 by 2, 120 by 2. This can be calculated from the aspect of option A. So, if you calculate that, the speed is going to be, the capacity is going to be, right, here 50, 60, 5, 6, 36, 0. There are 3600 vehicles per hour. But let us try to look at the option B. Maximum flow rate is 3000 vehicles per hour and the critical density is 60 vehicles per kilometer. But does it happens when the free flow is happening? When the maximum flow occurs, when the maximum density is, when the density is half of that kj by 2. So therefore here the jam density is 120 vehicles per kilometer. Here the critical density may be half of that from this relationship. So therefore here the Q can so happen that, here V is not given. Here V is not given. So one has to calculate the V from this relationship. There is a relationship that is given, 100 minus 5 by 6 into 60 into 60. So here 5 by 6 times of 60, 5 by 6 times of 60 can be 50, 100 minus 50. So this V could be 50 kmph. When if you want a maximum flow rate of 3000 vehicles per hour. So next, option C. If you read the option C, maximum flow rate is 6000 vehicles per hour and critical density is 120 kmph. From the fundamentals, that means from the definition of the density, we know that the density units are vehicles per kilometer. That means there is a contradictory. See here, the units of the density is given as kmph. So therefore, either this question can be objectionable or challengeable. This question can be challengeable, and this question can be objectionable. One can get a free mark for this question. And the next one is, so therefore it is inevitable that we may not be able to calculate further about the speed for the given maximum flow rate from the C. So let us move on to option D. Option D is free flow speed is given, that means Qmax is equal to 120 divided by 2, that means free flow speed divided by 2, 100 divided by 2. So it is somewhere close to the option A only. So therefore, if somebody wishes to give the correct answer for this particular question, the options would be either A and B, or otherwise it can also happen that that means B and D, that means option number 4. So one wishes to answer for this particular question, it could be either option 2 or option 4. Or if somebody wishes to challenge just because of this mismatch with the units of the option number C, one can go for the objectionable or challenge the question given in the TSPSC examination. So there are two options for this particular question. Moving on. The other question is the resistance of stones against grinding action under traffic is measured by. See, there is a term called grinding. In any of these first three tests, the material is not going to be grinded. Where in the abrasion, it can only be verified. It can only be verified for the hardness, how hard the material is. Whereas in the crushing strength test, we can only measure the compressive strength of the material. We can only measure the compressive strength of the material. But the option 3 is also linked to option 1. But what is attrition is? Attrition is all about the interaction that takes place between same materials or similar materials. So one has to realize that if somebody wants to answer it as option A, but it is also indicating that option C is also giving the same meaning. So therefore those two are not in the correct position. And the second option is all about the compressive strength. So therefore attrition is happening the interaction between the charge. The charge can be either sand or something else, charge and aggregate stones. So if you keenly look into any grinding process, whether it is a stone polishing or any grinding, even at home also you can look at the grinding processes. So grinding is always being linked to attrition. Or if it could have been polishing, stone polishing in the options, that could be the correct answer. But more relative answer is attrition. Moving on. Question number 43. A vehicle has a wheelbase of 6 meters. What is the off tracking in meters while negotiating a path with a mean radius of 60 meters? See here, a wheelbase is given. Usually in transportation engineering, wheelbase is defined by small l. So it is given as 6 meters. And what he is asking, what is the off tracking? Off tracking is always indicating the mechanical widening. So Wm is the off tracking of a vehicle. So he is asking basically the mechanical widening of a section while negotiating a curved path with a mean radius of 60 meters. 60 meters. So here the mechanical widening formula is NL square by 2R. But here the number of lanes, that means the N is not given. So it can so happens that we are bound to use L square by 2R. L square by 2R. So here L is 6, that means 6 into 6 divided by 2 into 60. So here this is 36, 2 into 60, 120. If you solve this, you will get option 0.30. This is the correct answer. Moving on. Question number 48. A road is being designed for a speed of 100 kmph on a horizontal curve with a super elevation of 7%. So there is a speed, the speed is given as 100 kmph, and then super elevation is also given. Super elevation is 7%. So always you should remember that when the values are given in percentages, when it comes to the super elevation, you have to substitute in fractions. So speed is given, super elevation is given, the friction is also given, lateral coefficient of friction is also given. Side friction means lateral coefficient of friction. Do not confuse with that terminology. And the minimum radius of the curve required for safe vehicular movement is. So basically the minimum radius is being asked. Minimum radius is being asked. So here what is the super elevation equation? What is the super elevation equation? The super elevation equation is E plus F is equal to V square by GR. V square by GR. And if you substitute directly here and try to calculate the R, see here V square, since it is in kmph, we would like to convert it into meters per second. So therefore we will multiply a factor called 0.278 to convert the kmph speed into meters per second. 0.278 into 100 whole square divided by, and here G is 9.81, that is fixed, and E is given 7%, so it should be written as 0.07 plus 0.15, and if you solve this, you will be able to arrive the answer somewhere around 357.9, and whatever the answer that you get is in meters. Just to get the answer in meters, we have been converting the speed from kmph to meters per second. Moving on, direct substitution question, and this question is little tricky. You have to apply your brain when you solve the question, questions something like this, right? Here there are conditions. There are two sections, basically it is a single section only, but if condition is used here. So rolling friction, that means Fr is given, and its gradient is plus G percentage for a section, but at the same time if condition is being used, if the grade of this road section is doubled, that means if G becomes 2G, percentage, right, what will be the percentage change in the braking distance? For the design vehicle to come to a stop, that means it is somewhere related to stopping side distance measured along the horizontal. Assume all other parameters are kept unchanged. This is so important. So here what he has been asking is, he is asking for the safe stopping side distance. Safe stopping side distance. What we know the formula of? The formula is Vt plus V square by 2gf. Vt plus V square by 2gf. But this is stopping side distance overall formula. But what is the definition of the stopping side distance? It is a combination of the lag distance and then the distance travelled during the application of the brakes. So it is a combination of two portions. But clearly we could see that there is no reaction time that was given in the question. So therefore this is overruled. Now what we have to calculate is, we have to calculate the braking distance that has been asked. So that means this particular portion of the formula to be utilized. So therefore the braking distance is equal to V square by 2gf, but at the same time he is asking that there is a gradient. So when the gradient comes into the picture, the formula is something like this. something like this, f plus or minus g. But this is for the case, in one case only, when g is equal to g percentage. But when g becomes 2g, then the criteria changes. So therefore, there are two cases here. In one case, g is remain g. In another case, g is going to be doubled. G is going to be doubled. So therefore, here the braking distances can be written something like this, right? So since all other parameters are being kept constants or kept unchanged, so therefore v square is common everywhere, that means speed is common here. So g is also common here. What is changed here is f plus or minus g remains there, because g is being changed, therefore its friend is also does not change. So here this is one kind of distance, but he is asking for the change in braking distance. What if the g going to be double? So this is plus 2g. Since he is talking about the positive gradient, let us utilize only the plus in the formula. So therefore this is one case 1. This is case 1, that means braking distance 1, and this is braking distance 2, and the difference between these two is so important for us. So this is FR, right? So B1 or B2 minus B1, anyone, right? What we need is, we need only the change in distance. So this is FR plus G minus FR plus 2g. Now this seems to be somewhere related to the relationship between 1 by x minus 1 by y. If you see such kind of relationship, we have to write down something like this: y minus x divided by xy. So if you solve this, the numerator becomes 0.01 g, and this is the only option we have got, the 0.01 g in the numerator. So therefore this is the option. Moving on, the next question is, the average spacing between vehicles in a traffic stream is 20 meters. That means the spacing is given, S is given, S is 20 meters. Then the density of the stream is what? So he is asking for the K. K is being asked. So here, what is the relationship between the spacing and density? They are inversely proportional. Sir, how? Why? If the spacing is larger and larger, that means the number of vehicles present in the section is smaller. If the spacing is smaller and smaller, the number of vehicles present in the section is going to be higher and higher. So therefore both of them are inversely proportional to each other. Spacing is equal to 1 by k. So here what he has been asking, he has been asking for k. So it can be written as 1 by s. Maybe this is 1 by 20. So therefore it will be option 50. 1 by 20 is 50. Because see here, he is asking in terms of kilometers. So if you convert this meters into kilometers, how do you convert? I hope everybody knows about it. So here, this can be written as 20 meters can be written as in kilometers 10 power minus 2, 10 power minus 2. So 10 power, if somebody wishes to write, write the solution. So this is when you after converting this will be 50 vehicles per kilometer. Moving on. So, option C. Question number 84. While aligning the hill road with a rolling gradient of 7%, a horizontal curve of radius r is 100 meters is encountered. What is the compensated gradient? See, first of all, to calculate the compensated gradient, we require grade compensation. There are two conditions for the grade compensation. Grade compensation can be calculated using 30 plus r by r or otherwise 75 by r. Whichever is smaller is considered as grade compensation. So, you solve this, if you solve this and the smallest direct substitution question, see here r has to be substituted here. So, that is 100 has to be substituted, 130 by 100 and this becomes 75 by 100. So, what is the smallest value? The smallest value that gives is 75 by r. So, that gives around 0.75. If we deduct this 0.75 in order to get the compensated gradient, that means CG, the compensated gradient can be calculated by deducting the gradient with grade compensation, that means 7 minus 0.75. So, this will give you something around 6.25. So, the compensated gradient is 6.25, therefore, the option number 4. Moving on. The question number 92. A linear relationship is observed between speed and density on a certain section of a highway. So, it is very clear that the relationship between the speed, flow, density is Qmax is equal to UF by 2 and Kj by 2. We know how it has been obtained from the fundamental relationship. There are 3 graphs which we have seen in the earlier in a couple of minutes ago. So, from there we can write the relationship of the linear relationship of free flow speed and density. So, here in the question itself he has mentioned that free flow speed. So, it is inevitable that we have to use this equation. And next another one is jam density. He is also given jam density. So, therefore, Kj is also there in the linear relationship. Density is estimated as 120 vehicles per kilometer. Based on the above relationship, the maximum flow expected on this section. What is the maximum flow? It is the maximum capacity of a section. And at the same time, he has been asking that the speed, this speed is not the free flow speed. He has already given the free flow speed, but he is asking us to estimate the speed at the maximum flow. Speed at the maximum flow could be, it is UF by 2. Speed at the maximum flow could be UF by 2. So, let us try to understand the options. Option number 1. So, it is given as, so or otherwise let us try to calculate. So, Qmax can be calculated using the given data. So, it is 100 divided by 2, 100 is 100 kmph is the free flow speed. So, 100 divided by 2 and 120 is the jam density. So, it is the divided by 2 and then it ultimately gives you around 3000 vehicles per hour. 3000 vehicles per hour. This is the maximum flow for a given free flow speed and Kj by 2, or that means Kj, traffic jam density. But at the same time there is a second question in the, there is a second part of the same question. The speed at which the maximum flow, speed at the maximum flow is UF by 2. So, this is This is 100 is given as free flow speed, 100 by 2 is the 50. So therefore 50 kmph is the speed at the maximum flow. So 3000 vehicles per hour and 50 kmph. So the answer is this, option number 4. Moving on. Consider the following statements. See here, the statements are something like this: running speed. We know that the speed definition is distance by time. Distance by time. But running speed definition is distance by running time. Here the time is not the whole time that has been spent in the journey. So distance by running time. Here that means running time means the time taken for the or the time measured during the running of the wheels only, not for the stoppages, not for the time that has been allocated for the recreational activities in the midway. Say for example, maybe you are traveling from Hyderabad to Vijayawada. Say there are 2 stoppages at one is at the fuel station, one is at the hotel. So the time that is lapsed in the fuel station is not going to be considered here when you are calculating the running time, and the time that you have spent in the hotel is also not going to be spent, not going to be utilized in the calculation of running time. That is purely the wheel running time. So therefore the running time is nothing but no delays. And there is another speed called journey speed. Journey speed. The journey speed can be calculated using distance. Distance is fixed between Hyderabad and Vijayawada, and in the previous case also distance is fixed between Vijayawada and Hyderabad. So here the time that has been spent during the entire journey, or the overall time, or this is also called as journey time, here it includes delays. So therefore the denominator of the speed definition is getting increased here in the case of journey speeds. Now let us try to look at the options. Option number A, consider the following statements. So here running speed is the higher than the journey speed. Will it be possible? When the denominator is so large for the journey speed, the overall speed is going to be decreased. When the denominator is smaller, that means it is only the running time without any delay. So therefore denominator is small, so therefore the distance is fixed here and here. So therefore running speed is always higher than the journey speed. And journey speed includes delays. Does it include delays? Yes, journey speed includes delays. Journey speed is the average speed. Journey speed is the average speed. No, running speed is the average speed. Sometimes we may travel at 30 kmph at speed breakers. Sometimes we may travel at 60 kmph when nobody is present, or when no vehicle is oncoming, or we are neither we following or nor the other vehicle is following us. So therefore the speed can be fluctuated during the entire travel. So therefore this journey speed is not the average speed. The running speed is the only average speed. So therefore option number C is overruled. Option number D, running speed is known as the overall travel speed. No, because the overall time is utilized only in the calculation of overall time is utilized only in the calculation of journey speed. But here what he says, running speed is known as the overall travel speed. No, so therefore option number D is also overruled. So we are only left with 2 options. One is option A and the other is option B. So therefore option number 3 is the correct option. Moving on. Match the following. Question number 103. See here, there are different signboards that are available or that we use on the highways. One is mandatory signboard, the second one is cautionary signboard, the third one is informatory or guiding signboards. Do not confuse with all this matter. What we have to look at is, we have to look at two fundamental things. One is the very first, very common thing that we observe on the road sections or on our streets is stop sign. Stop sign is always be octagonal. So option, whether this Roman number 2 is belongs to E or not, let us have a look at the options. So here we can clearly see that only option 4 is having E belongs to 2, and the other one, let us have a look at that. We know that all the prohibitory signboards are always been circular shape. So therefore there is a relationship between prohibitory signboards and circular in shape. This circular shape it can only be with mandatory signboards. So here the circular signboards are the prohibitory signboards. So option D is also having 5. So there is a clear answer with option D and option E. So therefore this becomes option 4. And no other options has these answers. If you know stop sign shape or if you know prohibitory sign shape, you will be able to answer this question. So because E belongs to 2 only, in any of the options E does not belongs to 2, and here D belongs to 5, and in any of the options maybe 1, 2, 3, D does not belongs to 5. So therefore in the only option 4 has got this combination. Moving on, the extra widening required for a 3-lane national highway at a horizontal curve of 900 meters radius. R is given as 900 meters. The moment you see the question, there is a multi-lane highway, that means number of lanes are 3, and the horizontal curve of radius 900 meters. Considering a wheelbase of 6 meters, that means small l is also given 6 meters, and here design speed of 100 kmph, that means V is also given as 100 kmph. But the first and foremost thing that we have to look at is, it is a 3-lane highway and it is a 900 meter curve radius. But from the fundamentals of extra widening, there are 4 conditions. WPS is equal to 0 on single lane roads, roadways. The second condition is, the moment you see the extra widening question, the 4 conditions that should be kept in mind always, whether it is AEE examination or GATE examination or IES examination. So the condition is, if the R is greater than 300 meters, no extra widening is required. That means extra widening to be provided on a particular section is 0. No extra widening. If the radius is much larger, and this can only for the 2-lane highway as per IRC, even if you see some old textbooks. But these days National Highway, IRC, Indian Roads Congress and NHAI have launched multi-lane highway manual, 6-lane manual, 8-lane manual. In that manuals also, it is clearly mentioned that no widening is required if the number of lanes are getting increased more than 2. So here, if the radius is more than 300 meters, for 2-lane only, no extra widening is required. Does it required for 3-lane? Does it required for 4-lane? No, absolutely no. So therefore, this option is here, the problem is in tricky condition. So here, if you solve with any of the part of the extra widening equation, you may not be able to get all these options. Any of the option, Whether you calculate only mechanical widening, no, you don't get any of these options. Whether you calculate psychological widening, you don't get these options. Whether you calculate combination of two of them, you don't get these options. So this any option can be answered for this particular question, or otherwise if somebody wishes to raise the objection, this question is objectionable, because the question itself is indicating that radius is 900 meters and for the radius more than 300 meters is extra widening is not required. The third condition is if the radius is less than 50 meters, that means the WE, that means extra widening, to be provided on inner lane only or inner edge side, on the inner edge side. But the fourth condition is if the R is somewhere between 50 to 300, sir, what to be done? What to be done? So this WE by 2 should be provided as half on either sides, on either sides. Very frequently asked questions, very frequently asked questions. So therefore it is inevitable that for any candidate that you are preparing for any PSC examination, GATE examination, AEE examination or IES examination, you have to remember these 4 conditions. The very first condition is no psychological widening is required on a single lane roads. The second condition is if the radius is more than 300 meters, no extra widening is required, not even for 2 lane roads. Then how about the 3 lane, 4 lane, 5 lane? It is not required. So therefore our question falls under this category. So therefore any option that is given in the exam can be taken as correct, or otherwise if somebody wishes to challenge this question by this 900 meters, one can challenge the question. Moving on, find out the length of the transition curve for a broad gauge curve of 3 degrees. So setting out of the curves, maybe in surveying subject or in transportation engineering subject of railway engineering, right? So here you have the relationship between degree of the curve and radius of the curve. So therefore here the degree is given as 3 degrees. Sorry, this is for a broad gauge track. This is for a broad gauge track, right? And then having a cant is nothing but here, cant is super elevation that can be denoted by E. So here the cant is given in centimeters. So if somebody wishes to write in centimeters, if somebody wishes to write in mm, it will become 120 mm. And the maximum permissible speed on the curve is 100 kmph. So therefore V is 100 kmph, 100 kmph, and the allowable cant deficiency is, that means say cant deficiency, let us denote it with D, and cant deficiency is given in mm only, it is 85 mm. And there is a clear cut formula. If you look at the railway engineering specifications given by Indian Railways, so here there is a clear relationship between speed and degree of the curve and the cant is clear. So there are 2 formulas to calculate the maximum speeds. Say if somebody wishes to calculate the maximum speed of the track, right, there are 2 formulas. One is that can only happen on the transition curves. There are 2 equations, right? So Vmax is equal to 134 times of L by E, where E is the cant, L is the length of the transition curve. This is the length of the transition, L is the length of the transition curve. Now what he is asking us to calculate? He is asking us to calculate find out the length of the transition curve. So L can be calculated using this formula. The other formula is Vmax is equal to, if you have the degree of the curve, so therefore it is 134 times of L by D. 134 times of L by D. Using any of these two equations, you can calculate the length of the transition curve. But smallest is possible. The smallest length should be considered. Smallest length of the curve using these two formulas should be considered as the design length of the transition curve. So therefore, see here, E is larger, E is super elevation, that means 120, E is 120 and D is smaller, that means 85 only. So here this may be written as length of the transition curve is equal to V max into E divided by 134, and here this can be written as L is equal to V max times of D divided by 134. Although you substitute this cant and cant deficiency in terms of mm, whatever the value that you get is in meters only. So here if you substitute the given things, speed is 100 kmph, so 100 into E is 120 divided by 134, and here 100 into 85 divided by 134. See now, since we know the concept of this length of the transition curve, the smallest possible to be considered as design length of the transition curve. See in the numerator, this 120 is larger than 85, so therefore the other parameters 134 is common here and here, 100 is common here and here, so 85 is smaller, so therefore it is inevitable to consider the length of the transition curve that has been calculated using this particular formula. So therefore the option, if you substitute and calculate, you will get something around 62 or 63. So the correct option is 62.04. Moving on. Next question number 139 of transportation engineering. The design speed on a road is 72 kmph. Assuming the driver reaction time of 2 seconds. So small t is also given, reaction time is given, speed is given, and the coefficient of friction, longitudinal coefficient of friction is given as 0.3. The required stopping side distance for a two-lane two-way traffic is, it should be considered as it is. So direct substitution formula, direct substitution in the formula. So SSD is equal to Vt plus V square by 2Gf. No gradient is given, no braking efficiency is given. So direct formula, direct substitution. So here speed is given in kmph. So you have to multiply a factor, as you know, 0.278 into 72 into number of seconds is 2, plus here V is 72, sorry, here the factor to be multiplied, conversion factor to be multiplied. So therefore this is 0.278 into 72 whole square divided by 2 into 9.81 into 0.30. Direct substitution problem. So here the stopping side distance required, if you solve this, you will be able to get the option number 3. Somewhere around 106.67 meters is the correct option. Moving on. So with this we can close the session on numerical problems on transportation engineering subject, which was given in AEE 2023 examination conducted by TSPSC in the state of Telangana. Thank you.